Hello friends, you are watching ISC Mathematics and we are solving exercise of chapter number 4 Determinants. In the last class, we have completed question number 6. Now today we will solve question number 7 onwards. So let us start the exercise now. Okay, we have question number 7. We have to find the value of the given determinants. The first determinant given is x plus lambda, x plus lambda, x plus lambda. Okay, now we have to find the value of this determinant. So with the help of properties, first we will simplify the determinant and then we will expand. Okay, so let us simplify. Okay, in order to simplify, what we can do is we can subtract from the first column third, means on C1 minus C3, and on C2 also C2 minus C3. So let us do that. On C1 minus C3 and on C2 minus C3 we will carry this operation. Okay, so now let us subtract first minus third. So the first column is lambda 0 and minus lambda. Again second column is 0, lambda and minus lambda, and the third column is x plus lambda. Okay. So we got quite a simplified form. Okay, one more step if you want to do, you can do. What we can do, we can subtract. Suppose if we are subtracting R2 minus R1, but it will be of no use, because if you subtract here you will get lambda and here 0. So let us keep up to here, and now we will expand along the first column or first row. So expanding, here you can take common, yes or no? If you want to take lambda common, you can take. Clear? Okay, one more step. If we want to do, what we can do is we can add, yes, on R3 let us add R1, so that one more 0 we will get. So on R3 plus R1, so we will add first row in the third row, so we will get, okay, lambda 0x 0 lambda x, and here 0 minus lambda and 2x plus lambda. So this is the simplified form. Now we got the two zeros in the first column. We can expand now along the first column. So let us expand. Now expanding along first column. Okay, so when we expand only the first term lambda and its minor, okay, lambda x minus lambda and 2x plus lambda. So let us solve this 2 by 2 determinant. So we will get lambda into 2x plus lambda minus plus lambda x. Okay, let us further simplify. So we will get lambda, okay, 2 lambda x plus lambda square plus lambda x, yes or no, which will be equal to lambda into lambda square plus 3 lambda x, and on multiplication with lambda we get lambda cube plus 3 into lambda x, yes or no? Or you can keep up to here, even if you don't multiply it will do. But let me check whether question number 7, number 1. Yes, that is the right answer only. Okay. So this is the right answer. You just take one lambda common, that's all. Okay, so lambda, if we take common, we will get lambda plus 3x. So this is the value of the determinant. Clear? Okay, so now let us solve the second question. Okay, now second question of 7, question 7. Second question is determinant containing element 0, a square b, a square c, ab square 0, b square c and ac square bc square 0. Okay, here we have to find the value of the given determinant. Okay, it is very evident. You can notice that here the first column contains a square in each element of first column we have a square, so we can take a square common. Similarly, in the second column we can take b square common, and from the third column we can take c square common. So taking a square, b square and c square common, we get 0 BC, A0C and AB 0. Clear? So we got this determinant. Okay, now if you want to simplify it, okay, otherwise what we will do, we will directly now expand, because we already have in the determinant 3 zeros. So let us expand along the first column. Okay, now expanding along first column. Okay, so a square, b square, c square multiplied by, okay, first element is 0, so we are not going to write that. Now second column element is b, so minus b, sign convention is minus b into, we have determinant AAC0, AAC0, again plus c into determinant AA0B. Now let us solve these two determinants. So we have outside a square, b square, c square into minus b into 0 minus ca, okay, plus c into ab minus 0. Clear? A into 0, 0 minus ca plus c into ab minus a into 0 will be 0. Now further simplifying, we get a square, b square, c square into minus minus plus abc plus abc. So a square, b square, c square into 2abc is equals to 2 a cube, b cube and c cube. So this is the final answer. So we have completed second of question number 7. Now let us solve the third one. Okay, question number 3 of 7. X square plus y square plus 1, x square plus y square plus 1, x square plus 2y square plus 3 and x square plus 3y square plus 4, x square plus 3y square plus 4, again y square plus 2, 2y square plus 6 and 3y square plus 8, again we have y square plus 1, okay, 2y square plus 3 and 3y square plus 4. So we are given this determinant and we have to find its value. Okay, so let us begin now. Okay, x square, let me first check whether it is x square, yes. Okay, now we will begin from the operation on C3. C3 minus C1 plus C2 we will do. Okay, so let us do that on third column minus C1 plus C2. Okay, so first and second column will be as it is, x square plus y square plus 1, y square plus 2, y square plus 1, again x square plus 2y square plus 3, 2y square plus 6, 2y square plus 3. Okay, now if you add x square plus x square, 2x square plus 3y square plus 4. Okay, and if you subtract, you will get over here minus x square only, x square minus 2x square minus x square. The first element, the top element of the third column will be x square plus x square 2x. So x square minus 2x square will be minus x square, 2y square plus y square, 3y square, 3 plus 1, 4 will get answered. Okay, in the second column 2y square plus y square, 3y square minus 3y square 0, 6 plus 2, 8, 0. So second term of the third column will be 0. Similarly 2 plus 1, 3y square and 3 plus 1, 4. So again the third term will also be 0. So now we got the two zeros. Even if you want to further simplify, you can simplify how? We can subtract from R2 minus R3 you can do. Okay, let us do one more step to further simplify on R2 or on R1 minus R2 and on R2 minus R3, these two more operations I will carry out, yes or no? From R1 minus R2, okay, so y square plus y square will get cancelled here, 1 minus 2 will be minus 1, okay, so we are left with x square minus 1, again here x square minus 3 and this term will be as it is. Okay, here 1, 2 minus 1, 6 minus 3, 3 and 0. Then we have y square plus 1, 2y square plus 3 and 0. Always remember that it is not necessary to follow all the steps. You got 0, now you can start expanding from the next step. You want to further simplify, as we have done, you can simplify. If you want to write more step of simplification, you can further do. Okay, for example, adding the second row in the third or subtracting the second from the third, you will get y square 2y square 0, etc. Yes or no? So in this way, if you want to do, you can further simplify. Okay, but now I will expand along the third column. So let me expand, or let me do one more step only. Okay, I will do what? I will add on R3. From R3 I will subtract R2, so I will get x square minus 1, x square minus 3 minus x square 130 y square 2y square 0. Okay, now I will expand along the first third column, expanding along the third column. So let us expand. So we have in the third column only that element is x square multiplied by the determinant will be 13 y square and 2y square. Okay, let us further simplify. So minus x square into 2y square minus 3y square. So minus x square into minus y square, which is equal to x square plus y square. So x square y sorry, which is equal to x square y square. So this is the final answer, simplified answer. Okay, as I told, remember that you can start expanding from the next step, second step. Okay, this is the question, first step. Right from the second step you can start expanding, you will get the same answer. So third of question number 7 we have completed. Now let us solve the fourth one. In the fourth one we are told to find the value of lambda. Okay, now fourth of question number 7. Three minus lambda minus 1 minus 1 minus 1 5 minus lambda minus 1 1 minus 1 and 3 minus lambda, which is equal to 0. In this case we are given an equation and we have to find the value of lambda. First we will simplify using the properties, the determinant on the left hand side, and then we will expand it and finally we will get the value of lambda. So let us start simplification first. Okay, on C1 we will add C1 plus C2 plus C3. On C1 let us add C1 plus C2 plus C3. So 1 minus 1 will be 0, so we are left with 3 minus lambda. Similarly you will notice that in each column we are getting 3 minus lambda in the first column. Yes or no? Then the second will be minus 1, 5 minus lambda, minus 1, 1 minus 1 and 3 minus lambda. Okay, we can take 3 minus lambda common. Yes or no? So let us take from the first column 3 minus lambda common. Now we are left with 1 1 1 minus 1, 5 minus lambda minus 1, 1 minus 1 and 3 minus lambda. Okay, now on R1 minus R2 and on R2 minus R3 we will do. Okay, so on R1 minus R2 and on R3 on R2 R2 minus R3. So we will subtract R1 minus R2 and then R2 minus R3. Why we are doing so? To get the two zeros. Yes or no? So okay, we have outside 3 minus lambda and first term 0, 0, 1. Okay, minus 1 minus 5 minus 6. So lambda minus 6. Then 5 plus 1. So 6. So 6 minus lambda and minus 1. Similarly here minus 2. Sorry, it will be plus 2. Then minus 3 minus 4 plus, so lambda minus 4 and 3 minus lambda, which is equal to 0. Okay, okay, done. Now let us expand along the first column. So expanding along first column, okay, we will get 3 minus lambda into 1 into the determinant will be lambda minus 6 to 6 minus lambda and lambda minus 4. Okay, now let us solve this 2 by 2 determinant. So 3 minus lambda into 1 into lambda minus 6 into lambda minus 4 minus 2 into 6 minus lambda is equal to 0. So 3 minus lambda into 1 into lambda square minus 10 lambda plus 24 minus 12 plus 2 lambda is equal to 0. We will simplify this expression inside. So minus 10 plus 2 will be minus 8 lambda. So we get over here 3 minus lambda into lambda square minus 8 lambda plus 12 is equal to 0. Okay, now we can factorize in order to get 12. Find two factors of 12. Sum is 8. So 6 2s are 12. So we will get here 3 minus lambda into lambda minus 6 into lambda minus 2 is equal to 0. Now equating each of the bracket to 0, we get therefore lambda is equal to 2, lambda is equal to 3 or lambda is equal to 6. So we have got here the three values of lambda. These are 2, 3 and 6. I hope you have understood this question number 4 of 7th question. Now we have completed question number 7 and now we are going to start question number 8, the prove that sums. So let us begin that. we are given the determinant a plus b plus 2c, c a, b plus c plus 2a, a, then we have b and c plus a plus 2b is equals to 2 into a plus b plus c the whole cube. Okay, let us prove this with the help of properties only. We will prove. So we will take left hand side. LHS is a plus b plus 2c, c a, b plus c plus 2a, a, b c plus a plus 2b. This is the left hand side. Okay, on C1 let us add C1, C2, C3. On C1 we will add the 3 columns C1 plus C2 plus C3. So the next step we get is a plus a 2a, b plus b 2b and plus 2c. So we get 2a plus 2b plus 2c. So take 2 common. So 2 into a plus b plus c, 2 into a plus b plus c and 2 into a plus b plus c. The second and the third column we will write down as it is a, b plus c plus 2a, a, b c plus a plus 2b. Okay, now we can take 2 into a plus b plus c common. Yes or no? So let us take that common. Okay, is equal to 2 into a plus b plus c common. The first column is left with 1 1 1. The second two columns says it is a, b plus c plus 2a, a, b a plus c plus 2b. Yes or no? C plus a or a plus is same only. Okay, now since we got the one, now you know what is the next step. Okay, on R1 minus R2 and on R2 minus R3. So now we will take this operation on R1 minus R2 and on R2 minus R3. So 2 into a plus b plus c. Okay, 0 0 1 b yes. So we will get here minus a plus b plus c, because the three terms will be minus a, minus b, minus c. So taking minus common we get minus into bracket a plus b plus c. Then a plus b plus c in the second term and third term is a as it is. Okay, b minus b will be 0 and here we get a plus b plus c minus of a plus b plus c, and the third term will be a plus c plus 2b. Clear? Okay, now notice that from the second row and the third row we can take the bracket a plus b plus c common. So a plus b plus c from the first row and a plus b plus c from the second row. So a plus b plus c the whole square, and we already have a plus b plus c bracket outside. So a plus b plus c into a plus b plus c the whole square will be equal to a plus b plus c the whole cube. So let us write down now the next step, 2 into a plus b plus c the whole cube. Now what is left? That is 0 0 1 minus 1 1 a, 0 minus 1 and a plus c plus 2b. Okay, now let us expand this along first column. Okay, I hope you have understood all the steps. Let us again go through all the steps one by one. Left hand side is given. Always keep in mind what you have to bring. On the RHS we want 2 into a plus b plus c the whole cube. I have done on C1 plus C2 plus C3. I have added the 3 columns on the first column. So we got 2A plus 2B plus 2C. In the next step we have taken 2 into A plus B plus C common. So we got 1, 1, 1. After you get 1, 1, 1, the common step which we always follow is R1 minus R2 and R2 minus R3. Or R1 minus R3 and R2 minus R3, anyway you can take. So we'll get 2 zeros, and then if anything further we can take common. For example, here A plus B plus C, A plus B plus C, from the first and the second row we can take common. So we have taken common, and now we will simplify. We will expand along the first column. Clear? So let us expand along the first column. Now expanding along the first column. So we have 2 into A plus B plus C the whole cube into 1 into the determinant is minus 1, 0, 1 and minus 1. Okay, further simplifying 2 into A plus B plus C the whole cube into 1 minus 0, which is equals to 2 into A plus B plus C the whole cube, which is equal to right hand side. Okay, so this is the required answer. Clear? So this was number 1 of question 8 that we have completed. Now we will solve the next question of the same question, question number 8. Okay, now question number 8, second one. We have 2A minus B minus C, 3B, 3C. Okay, 2A minus B minus C, 3A, 3A, 3B, 2B minus C minus A, 3B, and 3C, 3C, 2C minus A minus B. Okay, and on the right hand side we have to prove which is equal to 2 into A plus B plus C the whole square, or 2 into A plus B plus C the whole cube. I think we have to prove. Yes. Okay, so RHS in the previous question and in this question are same only, 2 into A plus B plus C. Almost the similar kind of question this is. You will notice that if we add on the first column the 3 columns on C1, C1 plus C2 plus CT, if carried out, then we will get A plus B plus C. Yes or no? Sorry, 2 into A plus B plus C we will get, and then we can take 2 into A plus B plus C common, and then as we had proceeded in the previous question we will proceed. Okay, so let us first write down left hand side LHS. LHS is 2a minus b minus c, 3a, 3a, okay, 3b, 2b minus c minus a, 3b, then we have 3c, 3c, 2c minus a minus b. So on C1 we will add the three columns C1 plus C2 plus C3. So we will get in the first column 2 into a plus b plus c, 2 into a plus b plus c, and 2 into a plus b plus c. Okay, second and third column we will write down as it is. Yes or no? So let us write down 3b, 2b minus c minus a, 3b, 3c, 3c, 2c minus a minus b. Okay, let us take 2 into a plus b plus c common. Okay, is equals to 2 into a plus b plus c. So we get 1, 1, 1. Then 3b into 2b minus c minus a, 3b, 3c, 3c, 2c minus a minus b. Okay, now since we got the 3 ones in the first column, obviously the next step is very clear. On R1, R1 minus R2, okay, and on R2, R2 minus R3 we will carry on. So on R1, R1 minus R2, and on R2, R2 minus R3. So 2 into a plus b plus c. Okay, here we get 0, 0, 1. Okay, so and here minus into a plus b plus c. Again 2b. Okay, minus. Okay, the first term will be plus only. A plus b plus c. Second term will be minus into bracket a plus b plus c, and the third will remain 3b only. Okay, here 3c minus 3c is 0, 3c. Okay, here a plus b plus c, and 2c minus a minus b. Okay, so now you will notice that the first column, first row and the second row, we have a plus b plus c common. So from the first row a plus b plus c, from the second row a plus b plus c, a plus b plus c the whole square into a plus b plus c, that is equal to a plus b plus c the whole cube. So let us write down 2 into a plus b plus c the whole cube, 0, 0, 1, 1 minus 1 3b, and 0, 1, 2c minus a minus b. Now we will expand along the first column to get the final answer. Clear? So now let me expand. Okay, now expanding along the first column, we will get 2 into a plus b plus c the whole cube into 1 into 1, 0 minus 1, 1, which is equal to 2 into a plus b plus c the whole cube into 1 into 1 minus 0 is equals to 2 into a plus b plus c the whole cube, which is equal to the required right hand side. also were similar kind of questions, first and second, and I hope you have understood both the questions. Now let us solve the third of question number 8. Okay, now let us solve the third question of question number 8. Okay, the determinant is b plus c, b c, a c plus a c, and a b and a plus b is equal to 4 ABC. Okay, now let us first take the left hand side. LHS is equal to b plus c, bc, a c plus ac, ab and a plus b. Okay, here let us on the first row R1 minus R2 plus R3 we will do. Okay, we will add the 2 so that we get b plus c, and then on subtracting from R1 we will get 0 over here. Okay, so let us do that. So R1 minus R1, R2 plus R3, if you do you get 0. Okay, here minus 2c, so minus 2c, and over here minus 2b we will get. Now b c, c plus a c, b and a plus b. Okay, now let us take 2 common. In the first row we can see that 2 is common, so we will take 2 common. Okay, so we have 0 b c minus c, c plus a c, and minus b, b and a plus b. Okay, now we got the two terms minus c minus b. So let us add the first row in second and third column. Yes or no? So on R2, R2 plus R1, and again on R3 also R3 plus R1. So we are going to add the first row to second and the third row respectively. So first row we will write down as it is. Okay, here B, here we get A, here 0, clear, here C, here 0, and here we get A. Now you notice that the determinant is simplified, yes or no, and we have got the 3 zeros even. Now you can expand. Okay, so expanding along any one row or column, we will expand along the first column. Now expanding along the first column, so let us expand 2, okay, into, now first term we are not going to take 0, okay, so we will expand with the second and the third term. So B, okay, sign convention is minus. I hope you remember this sign convention, plus minus plus, minus plus minus, and plus minus plus. Yes or no? The second element will be minus. So minus B into minus C minus B, 0A, again plus C into minus C minus B, A0. Okay, on further simplifying, minus B into minus AC plus C into AB. Okay, so we will get 2 into bracket ABC plus ABC, which is equals to 2, okay, 2 into bracket 2ABC, and which is equal to 4ABC, which is the required right hand side. Clear? So this question was quite easy. Okay, we have completed third of question 8. Now let us solve the fourth number. Okay, now third one we have solved. Now we will solve the fourth one. Okay, we are given a square plus AB, BC, B square and B square plus BC. Okay, again we have C square plus CA and C square equal to, we have to do 4A square B square C square. Okay, now let us take the left hand side first. LHS. Okay, LHS is A square plus AB, BC, B square plus BC, and we have C square plus CA and C square. Okay, now you notice that in the first column we can take A common. Yes or no? Because in each of the three terms in the first column A is there, so A can be taken common. Similarly, from the second column we can take B common, and from the third column we can take C common. So we will write down A, B, C outside, and now first column is A plus B, then B, again C, B plus C, and C plus A and C. Okay, we have taken common, so B plus C, A plus B, and C plus A and C. Okay, done. Okay, now this is almost similar to the previous question which we solved. Yes or no? So we can do something like that only. What we can do? Okay, on the third column, okay, we will add the two columns and subtract from the third column. So let us do that. Okay, so on C3, this, even on R1 also you can do. Okay, how? So R2 plus R3 on R minus R1 also you can do. So you can subtract anyway, either on C3 minus C1 plus C2, or on R1 minus R2 plus R3. Okay, so let us do that. Okay, so now if you want to do, let us take on R1 only. On R1 minus R2 plus R3 we will do. So we get, okay, A plus B, okay, minus 2B minus 2B and over here 0. plus B, 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 B plus C, and A and C. Clear? Okay, now notice that we can take minus to be common. Yes or no? From the first row. Clear? Or even if you don't take minus to be common, you take at least B common. 2 common. So let us take 2 common. So we will get your minus B 0, A plus B, B, A, B, B plus C and C. Okay, now what we will do, as we had done in the previous question on R2, R2 plus R1 and on R3, R3 plus R1 we will do. So we are going to add the first row in second and third respectively. Clear? So understood all this step. What was the first step? We have taken A, B and C respectively common from the first, second and the third columns. Then on R1 minus R2 plus R3 we have done, and then we have taken 2 common. Now we will add on R2 plus R1 and on R3 plus R1. Clear? So let us do that. Okay, now on R2 plus R1 and on R3 also R3 plus R1 we will do. Okay, so 2 minus B 0. Okay, A 0 A and 0 C C. Clear? So now we have 3 zeros. Now we can expand. Yes or no? So let us expand along, say, first row. Okay, so expanding along first row or first column, expanding along, let us expand along the first column. Any way you can expand, absolutely no problem. Expand along first row, first column, second row, second column, because in each column or row here we have 0. Okay, so you can expand anyway. So okay, now expanding along first column, so we have 2 into minus B, determinant will be 0 A C C, then minus A into determinant will be minus B 0 C C, that's all. Third element is 0, so we are not going to write that. Okay, now here 2 into minus B into minus CA. Okay, again. Okay, that ABC we took common earlier, that we forgot to write, so you don't make that mistake. Okay, in the first term only we had taken ABC common, so that ABC is already there, and then we took 2 common. Mind it. That step, this I have forgotten. I think in the 1 or 2 steps I did not write this ABC which we had taken common earlier. So you note down that. Okay, so here 2 ABC we have. Remember that it is 2 ABC outside, 2 ABC, and here also we have 2 ABC. Clear? So, and now here minus A into minus BC. Okay, now let us simplify. So 2 ABC into ABC plus ABC, okay, which is equal to 2 ABC into 2 ABC, which will be equal to 4A square B square C square, and which is equal to right hand side. Clear? Okay, so this one step, one term we forgot to write outside the determinant in 2 steps, I think 2 or 3 steps, so you please make a note. Okay, that ABC will come in each step outside the determinant. Clear? So we got the right hand side. Okay, Okay, so this was also a similar question, similar to third one. Only the difference was initially we had to take A, B and C common from the first, second and the third column. That was the only one difference. Okay, now let us solve question number 5. Fifth question of question number 8. Okay, number 5. What is the question number 5? Let us see. Okay, you are given the determinant x plus 1, x plus 2, x plus 3, x plus 2, x plus 3, x plus 4 and x plus a, x plus b, x plus c is equal to 0. Okay, A, B, C are in AP, it is given. It is given here that A, B and C are in arithmetic progression. Okay, A, B and C are in arithmetic progression. Okay, okay, done. We have to prove that the determinant is equal to 0. Okay, now let us take LHS. Okay, left hand side we have x plus 1, x plus 2, x plus 3, x plus 2, x plus 3, x plus 4 and x plus 4, x plus 5, x plus 6. Clear? So on let us begin on R3. On R3 minus R2 and on R2 minus R1. I am subtracting second from third and first from second. So we will get over here first row no change. Yes or no? Okay, then here subtract R2 minus R1, we get 1 and 1. Okay, over here again that is one mistake. Okay, here ABC is given and I have written 4, 5, 6, so let us correct this one. Okay, A, B and C. Clear? So we have here A. Okay, now B minus A here I can write then. Yes or no? B minus A. Okay, here 1. Again 1 and here C minus B. Clear? So now okay, we can subtract C1 from C2. So C2 minus C1 we will do in the next step on C1 or sorry on C2 on C2 minus C1. So let us write down C1 as it is x plus 1 1 1. Okay, here 1 0 0 and x plus a, b minus a and c minus b. Clear? Now we will expand along the second column because in the second column we have two zeros. So expanding along second column, okay, is equal to minus 1. Yes or no? Because the sign convention is minus for a 1 2 element. Okay, so let us delete the first row and the second column. We get the determinant 1 1, b minus a and c minus b. Further simplifying, c minus b plus a. Okay, so minus 1 into AC minus 2b a plus c, not ac. It is a plus c minus 2b. A plus c minus 2b is equals to minus 1 into 2b minus 2b. Why we can write for a plus b? In place of a plus c I have substituted here 2b. Why? Because it is given that a, b, c are in AP. Okay, since a, b and c are in AP, and it implies that a plus c is equals to 2b. Clear? So 2b in minus 2b will be now 0. So 0 into minus 1 will be 0, and which is equal to right hand side. Clear? So this was the last questions of question number 8 that we have completed. I hope you have understood all the questions which we have solved today. Okay, further exercise we will solve in the next video. Clear? Thank you very much.